All right, my name is John Franklin. I am with Sentai Digital, and I'm the Silkscreen CMS maintainer, and I'm here to talk to you about code signing for the web, how we're going to be creating digital signatures for Backdrop and Silkscreen CMS modules. Over the next 50 minutes, we're going to do a quick background onto what are Backdrop and Silkscreen, since not everyone has heard about them. We're going to do a quick primer on encryption. We're going to touch briefly on why we want to sign modules in the first place, and then we'll dive into the actual CodeSign API and how we're going to be deploying it through the project module and what we're going to be doing as we go forward. And hopefully we'll have enough time to have some Q&A at the end. So first off, Backdrop, if you haven't heard of it, forked off of Drupal 7 back while Drupal 8 was being put together. Jen and Nate Lampkin realized that Drupal 8, for all the power that it was going to have, was also going to be a lot more complicated, and they wanted to keep something that was more novice developer friendly. So they, at a judicious point in the Drupal 8 development, forked off, kept CMI, but didn't keep Symfony or Twig. They reduced it down to just MySQL and storing the config in JSON files, and that was as much for keeping the code base simple as a smaller project. But also for novice developers, it's a lot easier to, you make a change in a configuration somewhere and then you can very easily see, oh yes, it changed this value in this file here. They did add some new features, layouts and installer, or two of them. Layouts kind of takes the templates, the structure of a page out of the theme. So your home page is probably like, header, 2 columns, 3 columns, 2 columns, footer. That would be put into the layout, and it would leave the theme itself to handle more of the colors and graphics and logos and that kind of thing. They added a Drupal compatibility layer so that Drupal 7 modules can port with only a couple lines. For the simplest of them, it's like 2 lines in the info file to say, yes, this is actually, we can run this on Backdrop or Silkscreen, and then it just runs. They were kind of targeting the smaller sites, small businesses, nonprofits, community organizations, that kind of thing, and it was really intended to be just easy to set up and easy to build and easy to use. Silkscreen is what I maintain. It is forked off of Backdrop around 1.8. If you remember PressFlow in the Drupal 6 days, it's done very much in that style, where it tracks the changes that are made in Backdrop and releases within a few days of whenever they have a release, adding in all the stuff that they've done since the last release. So therefore it's a drop-in replacement for Backdrop. It includes what are kind of special modules. Postgres got put back in, but you can't have Postgres as a module because it has to be able to look up in the system table, should I even turn this thing on? How do you look it up in the system table when you don't even know the database is supposed to be there? So these here, the database, the config storage, and the caching are all special modules that by virtue of being in the drivers directory are automatically enabled. As much as possible, I try to contribute back to Backdrop because I know that anything I give them is just going to flow right back down into me in the next release. And doing so just keeps the drift between the projects as minimal as possible. Also, they're a great bunch of guys to work with. So I'm really kind of targeting sites that need a little bit more. Drupal 7 was able to build some pretty impressive sites, and I want to be able to still be able to do some of those more impressive sites without having to go up to Drupal 8. Let's do a quick background on just how encryption works. There are, when you're talking about encryption algorithms, 2 major ways of doing encryption. One is symmetric, where you have one key that both encrypts and decrypts at the same time. Asymmetric, which is 2 keys. Typically, one's called public, one's called private. Anything that is encrypted with one of them can be decrypted with the other. And then there's a third thing that we need to really deal with when we're dealing with digital signatures, and that's hashing. Being able to come up with, take a binary stream or a message of some kind and reduce it down to a number. And then do so in a way that there's not a likelihood of someone else coming up with a similar document that also comes to that same number. So yeah, something like taking A through Z, 1 to 26, and adding up all the numbers is a bad hashing algorithm. just because you can swap any two letters or move a not from one sentence to another, and you still have the same checksum. So real quick, just symmetric. Take the clear text, you pass it through a function with the key, and you get the ciphertext out of it. Do exactly the same thing, but pass in the ciphertext, same function, same key, and clear text. It's kind of like ROT13, if you remember that from the old internet days. Same thing, just encrypts or decrypts. Asymmetric. Instead of ROT13, think like ROT6 and ROT20. Anything that you pass through ROT6 can be decrypted with ROT20. Anything that you use ROT20 on gets undone with ROT6. So when we're creating a digital signature, we want to take advantage of that public-private thing. We hash the message. We then encrypt that hash with the private key. So when you've got the public-private key, if you want to send me a message that's encrypted, you would use my public key in order to encrypt it, and then I'm the only one that can actually read it. I mean, you could post it as a GIF, and I'm still the only one that's ever going to be able to understand what's in there because I've got the private key. In this case, we are encrypting with a private key so that everyone can verify that this is a hash that came from me. And in fact, that's what we do when we validate the signature. Someone will take the same thing, generate the same hash, decrypt the public with the public key to get what I sent as a hash, and if they match, then it's a valid signature. So a signature is an encrypted hash that validates the message. Signatures are tied to key pairs, because you have to be able to know which public key you're using in order to decrypt it. Key pairs are owned by a person or an entity. When we use them in the framework of GNU PG or OpenSSL or something like that, then there's always an identity that's tied to those key pairs. So the signatures don't just validate the message, they also tell us who sent it. When we start dealing with key management, that actually kind of becomes identity management as well. Because it's okay, so you got something and it claimed to be from John Franklin. Well, was it really me that sent it? Is it actually my key pair? Or is it someone else just creating a random key pair, writing John Franklin as the identity and sending it out that way? There are three major ways that we can manage this kind of key management. First is monolithic. We see this in OpenSSL and TLS all the time, where you get a cert, it's signed by something, it's signed by something, it's signed by something, and you keep following the chain up until you find a root cert that you actually trust, that's baked into the browser as something that is a trusted provider of identity. The other is a web of trust. I sign with Adam, so I trust anything that's coming from Adam. Adam signs with Steve back there. Do I trust Steve? Well, it's as much as I trust Adam to verify Steve's identity. But if I've signed with 30 people and all 30 have signed with Steve, well, now I've got 30 paths to it. There's going to be a little more trust than if there's just a path of one. And then the third way is called tofu. We use this on SSH keys all the time. Trust on first use. The first time you connect to a server, do you want to add this key to your known server keys? Sure. And then next time you connect, hey, this was different now. Something might be going wrong. Or maybe you just rebuilt the server and it's not a problem at all. But yeah, tofu is obviously going to be the weakest of them because it's kind of, you're not actually doing much verification. It just kind of happens. Before we go on, any questions on the encryption side? Great. So let's talk quickly about why we want to sign modules. The most obvious reason, we want to be able to verify the module's integrity. When we download the tarball, we want to be able to check. Before we even unpack it, we want to be able to say, yes, it didn't get corrupted in transit, no one is trying to pull a fast one on us, and yes, it's coming from a source that we trust. And that's actually the second thing is provide the identity of the developer. When we pull it down, it's going to come from the Backdrop signing service or the Silkscreen signing service. And so we can trust things that have come from the contrib library on backdropcms.org. But that's not the only way that we can do it. We could also have, Zivtech could have a key? And if it's signed by ZipTech, do we trust them? Well, if you're in Philly, then you know them, and then you know that they're a good shop. If you're living in Oakland, maybe you haven't heard of them. Provide the identity of the module itself. Rather than have the developers produce the signature, we're going to create a cert that is for the module itself. So this is the views module from Backdrop, or this is the paragraphs module from whoever the paragraphs module maintainer is. And that way we can say, there's a problem with this module, no one should use this particular version anymore, revoke the cert, and then it'll show up in the list of security updates says, hey, something is wrong with this, it's no longer allowed. You guys really need to update the module or pull it out from the system entirely. So in order to do this, we're leaning kind of towards the OpenSSL model, the monolithic cert chain. It'll start, of course, with the signing CA. That'll have an intermediate CA, because that's kind of logistics of how you do this kind of thing. You have one key that is the root, and you keep that someplace incredibly secure, like a thumb drive, in a safe, in a bank, at the bottom of the ocean, on a Jovian moon. And that way, it's a little inconvenient to actually generate a new intermediate CA from that root key, but that's a minor logistical thing, and it keeps it off the internet. It keeps it from being easily compromised. That intermediate CA then signs the Silkscreen module signing service, and that will sign each of the core modules and the contrib modules as well. But as I mentioned, we can also say, I can get my own, and I'll sign config session, I'll sign any of the sandbox modules that I have, and that way it doesn't have to go through a full release cycle, and yet you can still tell this is a module that has not been corrupted since it was published, in whatever form it's published. Some companies, like Sentai Digital, my company, could also create a signing key just for signing modules that are custom modules for a site. These are modules that are never going to make it up to backdrop.org. They're never going to be published anywhere else. But at the same time, we still want to be able to go through the whole security validation process and say, yes, these modules are as we ship them to the client. And the client will trust Sentai Digital because they're the ones that hired us. Any questions so far? So let's get into the CodeSign API then. CodeSign is a module that is in core. It is an API that is really just a kind of a framework for signing and verifying data. Despite the name, it's really able to do anything that you can pass in as a PHP string, it can sign or verify. So it doesn't have to be just code. It can be emails that you're sending in. It can be JSON that you want to save off. It can be pretty much anything. It manages the signing profiles, and I'll get into what that means in just a moment. It is the contrib modules that end up handling all of these specifics. So we didn't actually put in OpenSSL into CodeSign itself. You have to have a CodeSign OpenSSL module that actually handles the heavy lifting of the actual encryption and the digital signing. In core, there's going to be a hidden module that just does basic hashing. And this is mostly so that we have, well, two reasons. One, it is a good way to just kind of say, here's an example module of what you need to build in order to build a signing engine module. And it's also great for running all the simple tests to make sure that the framework is actually working the way we intend it to. There's an OpenSSL CodeSign that I've already written, and it's one of the ones that we're going to be looking at. There's also one for GNU PG, and I specifically wanted to write for at least two different ones, because that way I could pretty much guarantee that the API itself is signing module or signing algorithm agnostic. There is some interest in producing one for Sodium, so that's probably going to be one that comes along. And I'm sure in 5 or 10 years there'll be some new hotness in the encryption world, and we'll be creating one for that as well. But the idea was to make sure that we have the actual API separated from what's doing the signing, so we could pull and plug as we need to. The CodeSign API adds down in system CodeSign, a place where all the modules can stick in their own little tab and manage the profiles. Assigning profile is basically a profile name and all the parameters that are necessary in order to actually generate a signature. For just hashing, that's going to be, well, what hash algorithm are we using? But for OpenSSL or GNU-PG, that'll also be what signing key we're using in order to sign the modules with. There's a report page which just kind of puts out, these are the keys that are available on the system. So you can kind of see these, all the profiles that are there. And then there's the API itself, which is a really nice, and just try to keep it as simple as possible. So, sign and verify, those are the two major ones. But then there's the get signer status, which is basically each of the modules returns something here. So we can put together this page. Then there's also a get private keyring and a get public keyring. So modules that are consuming the CodeSign API as a service can use that to query and make sure that they've got the right keys available on the system for whatever they're trying to do. The sign and verify. The signer in all of these is just a string that refers to the machine name of the engine, hash, GNU-PG, OpenSSL. There's a profile ID, which is specific to that engine. The data that needs to be signed or verified. The signature block for the CodeSign verify. You'll note that the verify does not include profile. Pretty much if you're going to have a signature block, make sure that anything that is necessary to verify that signature is in the signature itself. So if you need a reference to the right public key, then make sure that that's in there. OpenSSL and GNU-PG do this by default. And then there's an options array at the end, which is added in. It's not currently used, but it's kind of there in case there's some module that needs some extra parameters passed through to it, then that was just a mechanism to make sure that that was possible. There's two other functions in there, a CodeSign get signature backends, which just lists all the engines that are currently installed, and the signing profiles, which gives a full list of all the profiles that are on the system. There's a theme that's defined. There's probably going to be a couple more as well. So CodeSign result. This is going to end up being used in, say, like you've got the module list. So you load up, admin modules, and you've got the list of all the modules, and we want to be able to add a little piece on the far side that says, these are the modules that are enabled, and we can do a CodeSign verification check on them, and they're green or red. There are a couple other places in the system where we're going to need things like that, and as we discover them, we'll be adding in more themes so that the modules themselves, the signing engines, can override those themes and add in a link to the cert chain or a link to a more info page or something like that. Defining an engine. We've seen this paradigm a million times in Drupal. It is a basic, hook info. It's not using the CTools version, it's just its own. But it returns something with a title, callbacks for all the various functions that we were going to be calling, and then a place where we can find all those functions. The CodeSign API itself will do a little bit of verification of the data coming in before it passes it off to one of the signing callbacks. So the way that we're going to end up using this is initially through the project module. Project module is something that's on Drupal.org, and it's also on Backdrop.org and Silkscreen.org, Silkscreen.cms.org, and BackdropCMS.org. Let me get those URLs right for posterity. That when you have a release, that's the thing that shows the available releases for a particular module and links to the issue queue, links to the GitHub repository. Anytime you've been searching for something on Drupal.org, it's that project module that's been presenting all the data that you've been looking for. So when we do a release for a module, that's when we're going to be generating the signatures. Project module itself has some hooks that basically say, hey, we're about to do a release. Anyone want to weigh in on this? Modules like GitHub might pull the right GitHub URL stuff from it. We're going to be adding in the digital signatures for it. The project CodeSign implements the new release hooks, and Project CodeSign, Project CodeSign is a module that supports the project module to generate the code signatures. And so Project CodeSign will call into the CodeSign API with whatever selected profiles are configured, and then take that, the CodeSign engine, CodeSign calls the engine callbacks. The CodeSign API itself calls the engine with profile ID. The engine itself signs the data and returns a signature, and then Project CodeSign takes that signature or signatures for the tarball and adds it to the XML catalog. And the XML catalog is whenever you do a check for updates, there's an XML file that's on Drupal.org, Backdrop, CMS.org, Silkscreen, CMS.org, that says, here's a list of everything that we've got published and the latest versions, and then the sites compare those latest versions to what's installed and says, hey, you need to update these, and hey, these are security updates. So we're going to be adding in the signatures into that. As far as, I mentioned signatures possible, because when you set up Project CodeSign, it says, here are the signature things that are available. Which ones do you want me to use? And you're not limited to one. You can sign it 9 ways to Sunday, and it'll stick all of them in there. And then it's kind of up to the sites to decide, well, which ones am I actually going to pay attention to? The XML that we're generating for this that gets shoved into that catalog, this is what it kind of looks like. Each one, it's just a list of signatures. Each one's a signature tag. List what engine is being used. List the profile ID, and then the actual signature block, whatever came back from the signing engine. If there's multiples, then it'll stick in 2, 3, whatever it is. I stripped out all the base 64 encoded stuff in here because it would just fill up the screen. But you can imagine that there's actual signature data in there. Project installer, this is the part that we're getting up to building right now, where as project installer is something that is in Backdrop that allows a site builder to say, hey, I really want to add in the web form module. So it pulls up the list of things that are on the site. This is actually running inside of whatever site you're building. And then you say install. It fetches the package, installs it, and gives you the option to turn it on automatically. It'll also do some dependency checks to make sure, okay, if you're installing web form, well, do you also need these other modules? Do you want to go grab them as well? So that's kind of where we are now. In the future, we're looking at doing more signing engines. Like I mentioned, Sodium is one that's going to be coming along. We are going to be looking at doing code signing of the core downloads as well. And we also want to do signatures of the modules themselves. Right now, the signatures are just for the tarballs that are coming down from Backdrop CMS.org. But we want to be able to say, okay, given a module, here's what's supposed to be in it, here are all the files, here's the checksums for them, the hashes for each of the files, and then we sign that so we have a whole signing manifest. It allows us to detect corrupted or hashed modules. Not entirely sure how to handle patch modules, because I know that on pretty much every site that I've ever worked on, there's at least one module somewhere that something's not working. I go into the issue queue, I see that someone else has had that same problem, they've posted a patch, I apply the patch, problem solved. It'd be nice if that patch were actually in a released version, but it's not, so we have to kind of work with that delta. Probably what we're going to end up doing is, in the same way that we are signing our own modules, our own custom modules, we'll just have to sign that as a patch module. It's okay, we did this, we intended to have it patched. And then we also want to be able to support revoking signatures, so that if there's a major security issue with a particular module, that we can just say, revoke the signature and anyone, when you look at the updates page, you'll say, hey, this one's been revoked, it's probably bad, go find the right one. And that's actually going to be more useful, I think, for abandoned modules, since those aren't going to show up. I guess they do show up as security updates, but they, security updates without anything moving forward. Being able to say strict code signing is something that we also want to be able to add in. So, a site will drop to maintenance mode or will just refuse to load if any of the modules fails its integrity check. And that's just, kind of protect the site from someone, they hack in, they drop in some extra code, and before they can even use it, it's shut down. And then, of course, code signing core, it wouldn't be just for the contrib modules, it would be for everything that we have in there. You can track it now in 1X. There is a release of Backdrop coming next week on May 15th, but we're not going to have it ready by then. So we're targeting September 15th, the Backdrop 1.14 release. Silkscreen normally releases within about a week of when Backdrop does, but with something like this, which is kind of, something I've been working on, is near and dear to my heart. It's something I'm going to try to get out the same day. So September 15th is a Sunday. I'll probably be working pretty hard on it then. Then, if you want to check it out, there's an issue 1992 in the Backdrop issue queue. That's the one that you'd want to check out. That's the overview of the entire CodeSign API and how we're going to be using it. Any questions? Okay, I blew through that a lot faster than I thought I would.